And Kubernetes sort of is the logical extension to as soon as you've got your feet wet with Docker, you start to ask a bunch of questions. Things like, I've built one container. Maybe I've built 3 containers and they need to talk to each other now, maybe a database and a server and a back end and a front end. And how do these things connect? Can we actually use these things to ship product to customers? Is another question we get a lot internally. Does that make sense? Or what are the use cases that work there? If I want to actually run containerized applications outside of my machine, how do I do that? What sorts of environments do I need? And so on. So this is where Kubernetes comes in. And, a couple of years ago, there was a real battle over container orchestration platforms. Docker Swarm and some others were popular. Kubernetes has effectively won the orchestration battle. So when we say container orchestration, we mean Kubernetes, and most people in the industry seem to have reached that same conclusion. So I wanted to show the high-level view of Kubernetes architecture, mainly to say, don't worry about this. If you start to read about Kubernetes, you can very easily land in a diagram like this, where in practice, most Kubernetes users don't need to know any of this. This is the internal architecture of Kubernetes, and things like kubelets and kubeproxy are processes that run to support Kubernetes, but end users don't need to know these things. So the message here is, if you do start your own Kubernetes investigation, don't get bogged down in detail. Instead, try to focus from the bottom up, and I'll show you that in a second here. Kubernetes is really interesting as a platform. You interact with it primarily with a declarative approach, meaning you build some configuration, you tell Kubernetes, hey, here's the state I'd like you to get to, meaning, I want a couple copies of my application stood up, or I want this network built, or I want something else. And Kubernetes will eventually get you to that state. So it's constantly listening and reconciling differences between the actual state that it sees and the desired state that you've told it you want to be in. And I'll show you some of that in a second. But some of the key Kubernetes objects that end users actually need to know, so as opposed to that previous slide, things that users really need to know are pods, services, namespaces, deployments, and others. I'll show you most of these, but getting started, you definitely need to know what a pod and a deployment and a service is. The good news for us is, as we've been playing through all of our uses of Kubernetes, a few times we've wondered, okay, something's not working quite right, or it looks like we have to jump through hoops to get something working. And you start to think that maybe you've got a unique problem that Kubernetes is not well built to solve. And in almost all cases, someone's already solved it. So there's lots of companies out there that are running their business on Kubernetes, doing tens of thousands or millions of containers being stood up. And so people have been through the battle here. And so most of the problems that we look for, in fact, I think all the problems that we're struggling with now, people have solved in one way or another. It's usually just a web search away to figure out how that works. So to get a grasp of the key Kubernetes concepts, I think it's better to start, as I said, from the ground up. And starting from the point of view of someone who has convinced themselves that containers are interesting, how do you then take it to the next level and think about Kubernetes? So if we start from a really simple example, let's say I've got a REST API that I want to make available as part of a Kubernetes application. And let's say locally, I've created a Docker image that knows how to, or that contains that REST API. So how do you start thinking about this in Kubernetes? In Kubernetes, you don't actually interact directly with containers or images. The kind of smallest unit of currency in Kubernetes is called a pod. In general, a pod has one container, but it can have more. But the best way to think of it is a pod equals a container for the most part. A pod gets its own IP address and can expose one or more ports. So in this case, I can stand up a pod in Kubernetes that exposes my REST API on its private network on port 8080 in this case. So I can do that, but that's generally not the best approach. The best approach is to wrap your pod in yet another abstraction called a deployment. A deployment is a way of provisioning replicas of pods. So one of the real values or benefits of Kubernetes is being able to spin up multiple copies of the same thing for a variety of reasons, for fault tolerance or redundancy or to handle load and so on. So if I want to stand up multiple copies of my REST API container, I can do that. And I can declare all of that in a relatively simple deployment. And I'll show you that in a second as well. The interesting part about deployments and pods is they are not accessible to anything running outside the cluster, and in some cases not even to things running inside the cluster. The way you expose your function is with yet another abstraction called a service. And the service plays a very, very important role. So the way Kubernetes thinks about pods is they are effectively ephemeral, meaning they can crash, they can get killed, they can get restarted, and that's goodness. We want the platform to be able to do those kind of things. If it sees a pod is in trouble, Kubernetes can kill it and restart it. The problem with that is if you had clients of that application who needed to respond to pods coming and going and knowing about how the network changed. So for example, maybe there's a new IP and a new port, that would be absolute chaos. So the service object provides that long-running network endpoint that abstracts away the fact that there's multiple pods behind the scenes. So a service gets its yet another IP address and can expose all of its traffic on any port it likes, but behind the scenes, it's calling one or more pods when someone interacts with that service. And again, the beauty there is clients can interact with this service on a known IP, known port, and the fact that pods might be coming or going behind the scenes is opaque to them. But even with services, you'll notice the IP address there. It's intentionally a 10.x IP address. By default, services are inside the cluster network unless you do extra work to expose them. So typically what you have is something called an ingress that is actually exposed to the outside world, and it knows how to talk to various services. And it can do that with proper routing, subdomain or path routing or whatever you need. And the ingress is usually where you do things like terminating TLS or monitoring traffic or other things. The important part here is that the way all of this hangs together is surprisingly simple. I'll show you in the configuration files, but the way a service knows how to refer to pods are really by this simple thing called a selector. It's basically a label, and all pods with that label are considered to be handled by that service. So yeah, it's probably best I'll show you how all this works. But then, as you build up a more complicated application, maybe you'll have more services and so on with different exposed endpoints. So all of that is, on the previous slide, was really about stateless applications, where it's okay for pods to come and go, perhaps. Stateful applications, where you need to worry about data and, pod can't just vanish and come back and lose any data that it's accrued. There are other abstractions for this. So in Kubernetes, they've abstracted away how storage is acquired and referred to. And so inside Kubernetes, a pod basically makes a claim for a persistent volume. It says, hey, I'm about to start up. I need a particular type of storage with a particular amount of available space. And that's all done in configuration files relatively easily. But it actually doesn't know how that storage request is going to get fulfilled. All it knows is something behind the scenes is going to go do that. Kubernetes then has other ways of provisioning that storage dynamically or statically. You can do it ahead of time. But basically, there's this loop that says, as a pod starts up, if it needs a certain type of storage, Kubernetes will see if that storage is available. If so, it'll bind it into the pod at startup time, and the pod will act, or it'll seem to the pod like the storage is just purpose-built for it. But in reality, it was done all by Kubernetes dynamically. So let's see some of this in action. Again, Kubernetes can get complicated, but you can also start small and hopefully build up from there. So we talked about a few things like pods and deployments and services. So I want to show you what these things actually look like. So almost all of your work in Kubernetes is going to be based on YAML. It's the kind of default configuration language for doing things with Kubernetes. So you'll get very used to YAML if you aren't already, and you start getting into Kubernetes. But basically, these YAML files are fairly easy to understand. In this case, so almost all of them will start like this. Basically, we're going to be interacting with the Kubernetes API here. And the API declares there's a type of object called a pod. And in this case, we're dealing with version 1 of the API. There's different versions. But what we're saying is we're telling Kubernetes, we want you to create a new type of object. In this case, it's a pod. We can give our stuff our pod, in this case, a name or some other metadata. The important part is down here. We're saying, here's the specification for this pod. It only has one container. We want to use the Tomcat container. And here we're giving the image tag. So if you remember back to Docker, I called my image myapp 1.0.0. In this case, we're saying we want to use the Tomcat image 8.0. And this lives out in Docker Hub. So if it's not local, Kubernetes will go find it in Docker Hub. And we're saying we want to expose our traffic on port 8080. And we can also set resource limits so that each pod, a single pod can't go blow up a whole Kubernetes environment. But as I said, you typically don't install just pods because effectively that's just getting a Kubernetes, it's getting Kubernetes to stand up a container for you. And you're not getting any of the value really by doing that. So instead what you do is you wrap that same sort of thing, that same pod specification in this larger object called a deployment. And so a deployment is a little bit more involved, but at the end of the day, it's doing the same thing down here. It's saying, here's the spec for the containers to install. We're just doing a single container, just like we saw in the pod. It's the same Tomcat version, same everything. The important part is this. We're saying, by default, just spin up one of these. And so let's do that. I'm going to apply this. So I've got this YAML saved. The way you apply this to Kubernetes is first you need your kube control command. This is the way, so just like in Docker where everything you need to do, you can do through the Docker command line. With Kubernetes, everything you do, you can do through the kube control command line tool. And so this needs to be configured to talk to some Kubernetes cluster. As I mentioned, if you're just getting started, you can use Docker Desktop and connect locally. In this case, I'm actually pre-configured to talk to a Kubernetes cluster we have running in Google Cloud because that's one of our main development platforms. So I can run kubectl or kubecontrol apply, and then you say, here's the file I want to deploy. So I want to apply this deployment YAML file. And that's it. So this is going to tell Kubernetes, hey, there's a new configuration to go look at and do something with. And you can see my deployment's been created. So just like in Docker now, I can start to interact with my system and see what's going on with a set of kube control commands. So for example, I can say, show me the deployments. And there should only be one, the one I just did. And I get some stats about it. I can see, oh, it's already ready. It's already up and running. It's been up and running for 18 seconds. So that's good. I can see the pods that were created. So let's take a look at the pods. This is showing me I have a single pod running, which is as expected. It's called Tomcat deployment, and it got some generated hash code here. It's been up and running, so it's good to go. And one of the beauties of Kubernetes, obviously, is the scaling. So literally, if I wanted to right now scale up to some number of pods, I can do that very easily. So I can do kubectl scale, and I need the deployment name, which is, I want to scale this deployment. And I want to now have, let's say, 10 pods. And so this is going to go tell Kubernetes, hey, go scale this up. Now if I do a get pods, I'll see there's 10. And some of them are in various states here. So some are pending, they're just getting started, and so on. So I've got the one that was running. It's been running for 88 seconds. The 9 other ones are just starting up because Kubernetes just kicked that off. There's even a more interesting way, especially when you're learning Kubernetes, to edit and change things on the fly. I don't think people use this in production very much because it's kind of dangerous, but you can do kubectl edit deployment, and then the name of my deployment. This is actually going to bring up a local editor on my Windows system here with the entire configuration of that deployment in my editor and ready to edit. So I can scroll down here to the replicas, right here. So we can see it's got 10 because that's what I just changed it to. I can change this back to, let's say, 3, save this, close my editor, and at that point, it's going to push that configuration I just changed back to Kubernetes. So now if I look at the pods, yep, it already deleted 7 of them. So now I'm back to just 3 that are running. So you can really quickly do things like this, scale and all kinds of stuff like that. As I said, pods on their own are kind of not interesting to run in Kubernetes because they're running inside a cluster network, and there's really not easy ways to access them, for example, from your browser. There actually are ways you can do port forwarding and other things, kind of like we did with the Docker publish, the -p command. But in this case, let's create a service so we can actually interact with our Tomcat application here. So now I want, and if we go back to the slides here, we've done this right now. We have a deployment. We've got a couple pods. In our case, we've got 3. Now we're going to add a service that talks to those 2 pods, but that's going to be the thing that exposes traffic to the outside world. So if I go back here, a service is just more YAML. And in fact, it's even simpler YAML. So in this case, again, we're telling Kubernetes we want to create a new API object, and it's going to be of type service. Here's its name. And the really important part, I mentioned this a little bit, but the really important line in here is the selector. This selector is a name that if we go back and look at the deployment YAML, it's got the same selectors for its pods. And so this is how the service is going to know what pods it can talk to. So it's a pretty lightweight mapping. It's a really interesting way that they developed this. That they could have done this much more complicated, and where you have to pass around IDs of pods and make sure a service knows all that. But it's a really lightweight way of doing it here, which is very helpful. So we go back to the service YAML. So it's got the right selector, and then again, the service can expose its traffic on port 80, but it knows to talk to the pods it's going to talk to on the port that they're exposing. So, and those can be different. And then I'm going to create a special type of service here called a load balancer. This is actually going to create me that under the covers, it's going to create me one of those ingress controllers. It's going to give me a public IP address for this service, as we'll see in a second. And this varies across cloud providers, but this is one of the things that Google Cloud and AWS give you is when you create a load balancer service, you can actually get it to give you a public IP address very easily. So Applying this is exactly the same as applying the deployment YAML. I just say kube control apply -f and the service, and that's it. My service has been created. So now I can inspect, let me just clear, get to the top here. I can inspect the service objects. Show me services, get services. You can see I have two running here. That's because Kubernetes itself has a service running. But the one I just created is here. And so there's my service. It's of type load balancer. It has a cluster IP, but under external IP, you can see it's pending. So what's happening here is Google Cloud is actually waking up and saying, oh, there's a new load balancer. Let's go give it a static IP address. And that should be done relatively quickly. If I do another get, it's probably going to be there. Yep. So now this IP address is actually live. So if I'm lucky, and this is exposed on port 80, so if I'm lucky and I go to here, yep, I'm at Tomcat. So this is Tomcat running in Kubernetes with basically just those two YAML files, the deployment YAML telling it what containers to start up, and the service exposing that traffic. Yeah, and then things can get obviously much more complicated. You can set up all kinds of things in Kubernetes. So for example, you set up your own networks, or you can install tools that will handle this sort of ingress much more specifically, so I can have different routes for all kinds of things. So what we've done here is very simple, but hopefully it gets you a flavor of how you interact with Kubernetes. So I did want to also switch and talk about Helm for a second. Helm is it's a way to package up Kubernetes applications and effectively hide the GORP that we just went through from end users. So, from our point of view as a software delivery organization, we don't want users to have to apply YAML files and maybe edit them and tweak them. We need a much more user-friendly way of doing that. And fortunately, Helm has been around for a long time. A couple of years, which is a long time in cloud native land. And Helm solves this problem by packaging up all of your configuration into basically one file, one tarball, and then giving users the ability to override settings really easily. And I'll show you what that looks like. There are other solutions for this. OpenShift from Red Hat has templates and operators and other things, which are different packaging mechanisms. And there's even standards bodies now thinking about, years from now, what are Kubernetes or cloud native applications going to look like, and how should they be bundled? But for now, from our investigations, we found Helm is the most effective one. It balances user friendliness with feature richness, I think the best. So yeah, as I said, it's a package manager. There's a very large community of public Helm charts, which is helpful for us. I should say Helm charts are the name of the files that get created that have all the configuration. I'll show you an example in a second. But really what Helm focuses on is providing a nice experience to install, update, rollback, and delete Kubernetes applications. So basically the key lifecycle parts of an application, handling those and making that easy to do. So if I switch over, if I just Google, for example, Helm charts, I land, the first hit is going to be over here in this Git repository. This is a curated set of Helm charts that the Helm and Kubernetes group provides. And there's a few sections in here. One is stable and one is incubator. Incubator is for new stuff that's coming, and there's lots of those that are kind of being tested. We tend to stick with the stable if we're testing things out, and there's lots and lots and lots of charts in here. Most open source projects you've heard of will probably be in here. Yeah, you can poke around and see what you want to do. For this example, I'm going to use Jenkins because most people have either seen it or played with it. So one of the entries in here will be Jenkins. With all of these Helm charts, especially the ones in Git repos, all of the interesting information is in the top level README, which is made available when you just scroll down a bit. And so usually you'll see something like this. Here's the way to install the Jenkins Helm chart. And so this is the user experience that excites us so much. So instead of worrying about YAML, instead of worrying about pods and deployments and other things, end users can focus at this level. I want to install the Jenkins application, so I'm going to use the Helm command line tool, which is yet another tool you need to download and install, but it's a single executable, very easy to install, and it just sits on top of your kube control permissions. So you don't need to do any extra configuration. But basically, you run this command. So I'm just going to run it. Okay, so I'm just going to paste this in, run exactly what it told me to run. And this is now, this has told Kubernetes a whole bunch of different configuration things to go do. And I can see that by, if I start looking at the pods, what I see is I have a brand new pod now called My Release Jenkins. It's just getting started. I should also have a service. Actually, I have a couple Jenkins services that are already being stood up. And yeah, so this is now deploying Jenkins. Let me just check the pod again, see if it's up. It's almost ready. So one thing I'm going to do here is you'll notice the Jenkins service is not one of those load balancer one. It doesn't have an external IP address. In this case, because I want to actually play with it, I'm going to edit that service using that dangerous way I talked about earlier. kubectl edit service and then the name of the service. This is going to bring me to a local editor with all of the configuration in it. I'm going to find the place that says what type the service is. In this case, it's cluster IP. I'm going to change that to load balancer, save it, and close the editor. And right away, I should already see that it's pending. Yep. So soon I will have a new public IP address just for this Jenkins service. Usually it takes 30 seconds or so. Oh, one other helpful thing you can do is on most of the commands, you can do a -W for watch. So if you're waiting for something to happen, you can do this and you'll just get an update when something's changed. So in this case, I now see my new IP address for my Jenkins service is successful. And just to test it out, we'll go to my browser, and I know it listens on port 8080, and there we go. We're on Jenkins now running. And if you remember, the entire install process was that one-liner. It was basically install Jenkins with Helm. So much simpler install process. I will show you one other thing just because it's interesting and it's a nice pattern for deploying applications in Kubernetes, or at least I think it is. And that is, if I do a Helm status, my release was called my release. This is going to give me information about that thing I just deployed, Jenkins. In here, you're going to see some information that they provide. In this case, the Jenkins Helm chart creator provided to help us get started. And so you'll see in here, by default, it says there is an admin user if we want to log in, but there's no default password, or at least not a human readable one. The default password, the password has been generated and actually stored inside a Kubernetes secret, which is yet another part of the Kubernetes API. A secret is another object where you can have encoded text and other things stored. So it's telling me here how to get that information out. So I can run this command to get my generated password. There it is. So basically you can hopefully see what it's doing here. I was running kubectl get secret. I'm in a particular namespace. I didn't talk about namespaces, but inside Kubernetes, there are ways to isolate applications from each other, and those are with namespaces. So you can install application 1 into namespace 1 and application 2 into namespace 2, and they will know nothing about each other in general. And then it's saying, here's the Helm release. Oh no, here's the name of the secret. And then it's getting out a particular piece of data, which is my Jenkins admin password. It comes out base 64 encoded. So then I'm piping that to base 64 decode, and this -i is for ignore garbage. So that's my admin password. So if I copy this and go back to my Jenkins and sign in with that information, I should land in a working Jenkins environment. So again, this is it's really good for getting up and going with demos, for example, or trying out new tools. We want the install and usability experience of our production grade applications to be just as simple. So one thing I wanted to leave you with Helm was the fact that you can find examples of that kind of thing too, where the default is sort of a demo environment, and then information on how to make it a production environment, all with just a few configuration files. So if I look for WordPress Helm chart, they did a nice job, so that's why I'm pointing to their Helm chart. When you scroll down here, again, they have the simple one-liner install, which is nice. That's going to get you a bunch of default configuration, usually meant for demos or trying things out. If you scroll down a bit, there's all kinds of things you could override. And these overrides are with simple little switches you just put on the end of your Helm install command. So it's still a one-liner to install, even if you're overriding these things. But down at the bottom here, they've got a section on production configuration. So if you want to install WordPress in a production, like a high availability type thing, they give you the exact values you need to override. So, I want to use 3 replicas instead of 1 pod, for example. I want to set traffic policies a certain way. I want to set my persistent volumes a different way. So this is the sort of way that that we can support both simple, quick installs and production grade installs with sort of simple overrides. One other thing I'll show you, just to give you a sense for how simple these overrides are. If I wanted to install, let me delete the Jenkins install I just did. I can do a Helm delete my release, which is the name that that I told Helm to use. I can install that same Jenkins thing again, but this time I'm going to override a value, and I just do it like this. I'm going to set, and I better check it here. 1 second. Jenkins Helm chart. This time I want to set the admin password so I don't have to actually look it up. And so if I scroll down on the Jenkins Helm chart page, I'm going to see at some point here there's a value I can override called the master admin password. So for my command line, I would just do this. Maybe I want to make the admin password admin. And that's it. And then if I had more values to override, I could put them all in a file and apply it with a -f here. So, but that's it. That's the way you override default choices in Helm charts. And if you ever start investigating this more, the really nice thing about the fact that all of these Helm charts are public and out there in GitHub is you can poke around and see what they're doing. So a Helm chart is basically, as I said, a bunch of Kubernetes configuration. It's going to be much more complicated than the examples we looked at. So for example, here in Jenkins, if I go to the templates folder, I'll see lots of different YAML files. Some of them are what we did. So for example, this is a service. The first couple lines look the same. This is declaring a new type of service. But then there's all kinds of stuff in here about overriding things. So all of these are templated values that could be overridden. So a bit harder to read these, but at the end of the day, it's doing the same thing. It's providing the Kubernetes YAML configuration to deploy Jenkins, and that's it. So yeah, I hope this is useful. Obviously, lots more we could get into, but in the time we have here, I think hopefully you got enough of intro to whet the appetite and investigate further. Thank you.